Hi everyone, so today we are looking at the halogenation of an alkene, and all this means is we are taking a halogen, so something like bromine, chlorine, fluorine or iodine, and adding it to our alkene, which today we are looking at ethene, okay, so our simplest alkene. So this reaction is a little bit different than those that we've covered so far, but we'll walk through it step by step. The first thing, it's actually the same that we do all the time, is identify or just acknowledge that we have pi electrons floating around that double bond, okay? Usually what we'd say is, okay, they're going to be attracted to something that's maybe has a partially positive charge. But when we look here, what we have is Br2, okay, bromine, and the bond between bromine and bromine, because they both obviously have the exact same electronegativity, is non-polar. So how is this reaction actually going to occur? Well, if we think of this occurring in a vessel, okay, so think of these molecules moving around and interacting, okay, and we think there are electrons around them. Now, electrons repel other electrons, okay, so if they bump into each other, they'll move away, okay, they try and stay away from each other. So if these pi electrons come into close enough contact with the electrons on this bromine, which is closest to it, the electrons here, they actually push away from it a little bit, okay? So what happens is we get a movement of electrons going this way, and we represent it by this arrow, okay? Now, because that happens, and we have a movement of electrons going towards this arrow, this becomes slightly delta positive, okay, or positively charged, and this becomes slightly negatively charged. Okay, so we have a delta positive and delta negative. And now we're kind of back on the same footing that we'd usually be, but it is important that you acknowledge that slight difference, okay? And what we've done here is we have induced, okay, we have an induced dipole. So that's important for you to notice. And what happens is this bromine here basically becomes our electrophile, which we can acknowledge with E+, and this our alkene here is going to be our nucleophile, okay? So just to acknowledge that. And what will happen now is these pi electrons will move here and form a bond with bromine. The bond between bromine and bromine will break. And again, because this bromine on this side is more electronegative, it's going to steal that red electron too, okay? So just remember that. Now, again, a new step. These electrons on this bromine are also going to interact with this carbon. So we have two new bonds being formed here and one bond being broken, so just keep that in mind. And when we do that, we get a new intermediate that we haven't encountered before. So we're just going to draw that out. So all our hydrogens have remained the same here. We've broken the double bond here, and in its place, okay, because remember we had, I might actually pop it in red, we had a bond being formed here, and we can say that's this one here, and we'll put this one in blue, and even mark those in blue for the moment. We had a bond being formed here, and now that's occurred here, okay? So now what we have is something known as a bromonium ion. Bromonium ion, okay? And when we have an ion, there has to be a charge somewhere, okay? So we have electrons here. This bromine now has a positive charge, a formal positive charge, okay? It does not want that formal positive charge. When you think of halogens, they are extremely electronegative. They want to attract electrons, okay? So having that positive charge is not an ideal state for it. And because bromine is more electronegative than carbon, it's going to start pulling some of those electrons up this way, okay? Which means that this carbon down here will have a slightly positive charge, it will be delta positive, okay? So again, it's just something for us to keep in mind. So what is this going to react with? Well, it's going to react with the halide ion, okay, or halide anion, that we had up here earlier. Okay, so earlier this had 1, 2, 3, 4, 5, 6, 7 of its own, and it stole one when that bond was broken. So now it has one extra electron, so it has a formal negative charge. And this now becomes our nucleophile. Okay, so this is our nucleophile, and therefore this is our electrophile, okay? And, sorry, that should be a plus here. It's very important, okay? So delta positive here. Carbon, it has a slightly positive charge. And when we have opposites here, okay, we have a partially positively charged carbon, we have a negatively charged bromine. These two are going to interact. Now, bromine cannot attack this way. It cannot attack this way because this bromine here is already blocking it off, okay? So physically it just can't fit in. So what it'll do instead, it will attack from below. So we can show our movement of our electrons, and it's attacking this way. Okay? Now, because this is more electronegative, it's going to pull those electrons up towards itself. So we're going to have one bond breaking between this bromine and this carbon here, and one bond forming between this carbon and this bromine here. Okay? And when that happens, we end up with this. So we have a bromine up here from earlier. Our new bromine has gone down here because it couldn't attack from the top, and everything else is a hydrogen. They never change throughout the reaction, okay? So again, we can pop in our electrons. So bromine is now happy again. Same down here. So again, you can count your bonds just to make sure everything is wrapped up. So bromine can only have one bond each. It does, and it has all the electron pairs that it should. So we're happy out. Hydrogens are fine, one bond each, and carbon has 4 surrounding it. So it's perfect. And all that's left to do is name it, okay? So we have 2 carbons in the middle in our longest carbon chain. They have no double bonds, so we're going to be dealing with ethane. We have 2 bromine groups. They are functional groups here. So we have 1 on carbon number 1 and 1 on carbon number 2, whatever way you do your numbering. So we are going to end up with 1, 2 dibromoethane. And that is our product. So we've zoomed out, and we can see our overall reaction here. As I said, it is slightly different this time. It does take a bit more thought, and it definitely does rely on you understanding how electrons may behave a little bit more. But with practice, it'll get a lot easier, okay? So we have a new intermediate. This time we have a bromonium ion. We're getting used to identifying our nucleophiles and our electrophiles, and again, our curly arrows. So give this one a go, practice it yourself, practice explaining it to yourself, and practice it with friends, okay? And see how you get on.